Hello guys, I'm back, Patrick from the Backyard Science Lab, and today I'm mixing two of my favorite things, and apparently you guys' favorite things since they were my two first liked videos, Oobleck and a vacuum chamber. And now, what I thought was interesting about Oobleck is if you haven't seen it, I'll probably put an iCard in with the vacuum chamber up in the corner. And Oobleck is a non-Newtonian fluid, which I go over in that video, where basically if you strike it, it becomes hard. And you can see that when I put my finger in it, it's liquid, but then when I try to pull it out, it suddenly turns hard. And now I was thinking about the forces that when I put my finger into, or when I punch this would be applied. But there was an interesting force that I guess I didn't think of before, and that's of air pressure. And now air pressure is constantly hitting this. And while we don't usually think of it, that's because our bodies are immune to this and accustomed to it, where our skin is made to reflect the 14 pounds per square inch of atmospheric force that we have. But this Oobleck, I manually made it so that it would be normal under 15, 17, whatever it is, pounds per PSI of force on it, where it works at this air pressure. But that got me thinking, if it works at this air pressure, then if we put it in a lower air pressure, would that mean that it would actually become more liquidy? So I wanted to try this, and I'm not sure how well this will go, but I'm going to try to get this Oobleck into the vacuum chamber. And now I have to pour this slowly, because if I don't, it'll just, I'm not pouring too much, but it should be fine. We also may be able to see some cool moments of degassing, or what is cold boiling, which I actually just filmed the same day that I'm filming this one. They'll probably be out in different days, but okay. So we are going to hook. If you've never seen this, I hook the thing on, or the cap on, and hook it up to the rest of my system, which has one-way valves and this air pressure meter. I actually got this from an Action Lab subscription box, which you can get with, I'm not promoting this as a promotion, but yeah. And you can see the pressure climbing here and what's happening in there. And now, so actually I'll take, well, this isn't too high pressure. You can actually see, it looks like it's starting. So this one, when I shake it, it starts to become hard. But this one, even at very low pressure, taken away from it, it still seems actually very liquidy, which is interesting. And I will take down some more. We are, okay, well, there. We're at like 0.6 atmospheres. So that means this is 60% of 60? I think so. This is about 60% of what you are feeling right now. Past -20 psi. I'm going to try to get down to -25, even though it's very hard to pump at -25, because as you can see from this pump, it just kind of brings it back for you. This is at, yeah, just a little bit above. I'll get it exact. OCD, kick hand. Okay, whatever. So let's see. So this is extremely liquidy. Look, it's not even turning hard at all when I shake this. So I also wonder that when we put the pressure back in it, if it'll harden up in some weird shapes because of the force blowing at it. So I'll push this aside and try to depressurize this. So you can, very liquidy. More liquidy than this, underwater. It's like it's permanently made it liquidy. Huh. Is this any different? I want to test it in here. Oh, now. This vacuum chamber's still very blue. Just by me scraping the side of this, I feel like it's not as... No, it's definitely more sticky, way more sticky. While it's not like perfectly more liquidy, you can see that like it's way more sticky and that when I do try to punch it, I get it all over myself. Yep, definitely get it all over myself. But I did want to try one other thing, which would be making it too hard of Oobleck. And I've made this sometimes where I've accidentally put too much cornstarch in it. I'll just add more cornstarch to this, where it becomes, in the open atmosphere, way too hard to hit, where it's just solid all the time. So I want to see that if we put it in here, will it become liquid again? And I'll cut to when I have it all in there. Guys, I'm back, the backyard Smurf man. But anyway, I put a lot of cornstarch in this, and now it is super hard that it's not even liquid anymore and pretty much just damp cornstarch. You know, I actually didn't think of how I get this in here. But I want to get this in here and see if it liquefies at all. This is a way over extreme. You mean there's a lot hard versions and not completely solidified things I could have done, but you know how we do it here. But yeah, so I'm gonna put all this in here and see how it goes. You can see how hard this is, that there's open spots. And I'll just shake it real quickly for you, just as a control test. That, yeah, sure, maybe moving, but it's moving because it's dry clumps of stuff. So I want to put it in here and see if it liquefies at all. And now, when you think about it, 14 pounds per square inch is a lot. Like, imagine having 14 pounds of weight on an inch spot, square inch of your arm would hurt. So taking away, I can't take away all of that. That was loud. Can't take away all of that 15, 14, 17, whatever it is, pounds. I don't know. Somebody can tell me in the comments if you're an expert and you know it. Okay. And but imagine all that weight getting lifted, it would be a lot different. And you can actually see it. Look at it liquefying now. Kind of see how much air I'm taking out of this. Each one I'm taking a syringe full of air out of this jar, so not much air left in here now. I am just about 0.8 atmospheres. I said negative atmospheres earlier, didn't I? Never mind. And I'm at like negative 25 psi. Or minus. Okay, so I'll stop that. I actually saw some bubbles during that. And while I don't think it's liquefied, I would say that it has liquefied in some sort because it's filled in the gaps and it's not just a solid thing anymore. So I'll actually see if it's liquidy now after we take it out. Hear the pressure there. Lift this up. I need a new bowl for this. It does feel, I know there's no actual scientific way to put this, but it does actually feel damper. You can see that I can squish it and almost mold it together. Just make a little spot right here. Try to use the spoon. Okay. I don't want to make this go on for too long, but I'm really interested in this stuff. Yeah, so you can actually hear it, how damp it is, and its crushing sounds. See how much. I'll put these next to each other because I still have some of the other one left. So you can see that this one that I put in the vacuum chamber is much squishier and more clay-like actually. And then this one that I have here, first of all, other than it feeling like a very, very dry clay, it's very, very grainy. And you can see that when I use it, it just kind of falls apart in my hands. But anyway, if you enjoyed this video, you can subscribe. Although after editing, there was one more thing that I wanted to try. So this is post video, but I had an idea. So I wondered that when we poured this, of course it was taking the top oobleck. Was the top oobleck thinner than the bottom oobleck? Now to try that, I want to add a little bit more water to this stuff that we put in, the hard stuff that we put into the vacuum chamber earlier. Add a little bit more water to it. Mix it up just so that I can barely use it and mold it with a spoon. And then use it with the two to make. So yeah, you can see that just by adding a little bit of water, it's still very hard that I can't get my spoon in there, but it is a lot better. You can see it shakes around a little bit, but it does become hard when you shake it too much. It actually seems like there's a lot of water on top, so I'm gonna mix it back in. Yep, there's like 2 layers here. It's funny, this already makes 2 layers, a water layer and a cornstarch layer. And so my idea is, if this still makes it more liquidy, is it that it's just a coincidence? Or is it that maybe the water and the cornstarch bond differently with each other? More chemical standpoint there. So it is actually very solid at the bottom. Surprisingly solid. Okay. So you can see how much I can mix it around there. It was still very hard though. And you can see when I shake it how it turns out. Still gets hard, but it doesn't shake that much. So now I want to put this back in the vacuum chamber and see if there's a difference. And now the point of this may seem kind of obsolete, but the point of this was I'm going to be measuring the same thing. When I was doing the other thing, I was measuring, while they did come from the same thing, 2 different things. As the top layer experienced different mixing and different being put into the vacuum chamber. So I want to keep it as least variables differ as possible. And now while this vacuum chamber isn't very clean, because I was just shaking everything up, hopefully you can find the cleanest side and see if you can look inside. I'm not expecting it to do much while it's in like this, but we don't have a seal. Okay, we don't have a seal. I'll come back when I think I can get a seal. Okay, we found out it was too much cornstarch on the lid. But to show you this again, how liquidy it is, I can grab some of it and let it drip down. Just to show how liquidy it is at its most liquid state. Well, okay, so I'll try to get this lid back on. Okay, and I'm going to start pumping. We're already getting much more pressure. You can see it climbing quickly with each pump. Still isn't very cleaned out there, but we're just about 0.8 atmospheres. looks like a spring at this point when it pulls back in, or like a reverse spring. They have those in car suspension, don't they? I made a car suspension. Okay. So I think we have just about -25. Sorry. Okay. So I'm going to break this. Well, I'm actually going to shake it. It seems more liquidy. It really does seem more liquidy. And I'm not sure how well you can see this, but it really does seem to be able to climb up the sides and wiggle around. So I'm going to release the pressure. Okay, there we go. Don't want any water anywhere. Okay. Then release the lid, which is apparently hardened with Oobleck onto the container. This feels, this is seriously much more liquidy. You can see there's no clumps in it. The other ones seemed like it had some bigger clumps. When I pick it up, you can see this, how fast it starts to go down and how fast it does go down. It's actually kind of funny when those two streams collided, they hardened. But it, yeah. You can see it wiggle around from the top. I'm going to take some out onto this countertop, see if I can study any better here. Okay, there we go. Oobleck, while it may seem pretty hard, is actually very easy to get off of countertops, because if you move it quick, it's like a solid, so you can just pick it up like a pancake, just like, whoop, whoop. But anyway, yeah, you can see how runny this is. It's like normal Oobleck again, which it wasn't. It was very hard Oobleck last time. You can see how I'm able to just punch it without it doing that, but also letting my finger slide into it. Well, there's not much deepness to play with in here, but... Okay, so today we found that that when put under a vacuum chamber, the chemical composition of Oobleck does change. It makes it much, much thinner, as we can see here. It makes it much, much thinner, and while it's under vacuum, it's much, much thinner because of, presumably, the chemical composition change and the atmospheric pressure change. But wait, before you guys leave, I have to tell you about the Backyard Science News, and that is that there will be a Falcon 9 launch May 27th, which is Memorial Day. The time is not posted yet, but keep up to date, subscribe, and like this video to hear all the next news. Also, if you would like to be part of my video, I know just about 2 weeks ago I posted a video with my friend Ethan where I made a bamboo bridge, and I have a couple other people that I've wanted to make a video with. But if you want to be in one of my videos, you can email me at thebackyardsciencelab@comcast.net.